Okay, so now let's talk about what if we don't just want to stretch it and flip it? What if we want to do something else to it? So this is the stretch or the flip, right? Those ones here. But what happens when we have something either subtracted inside the root or added at the end? So these are what's called a translation, either horizontally or vertically. So I'm going to kind of break it down for you so it's not so foreign, okay? Keep in mind that your parent function is always going to be this root with the x. That's going to be your parent function that we compare everything to, okay? The number in front here, I'm going to highlight it in red. Okay, the number in front here, this a, is always, whatever number is multiplied in front is always the vertical stretch or shrink, okay? It's a stretch if it's greater than 1. And it's a shrink if it's less than 1. Okay, so there's kind of the code to that. Whatever number's there. Also, if it's negative, there's a reflection. Okay, so if a negative, then it's a reflection where it also flips. Okay, so now let's look at this number out here. This is the k value. Notice that it's also outside of the root. Any numbers outside of the root are some sort of vertical change. So we call this a vertical translation or a slide. Okay. And if it's positive, we go up that number of units. And if it's negative, we go down. Okay, pretty standard. So if this is plus k, that means we would go up k units. Now, here comes the tricky part. This number here is inside the root. Inside the root, anytime you're inside or attached to that x, that's the horizontal changes. Okay, this is a horizontal because it's on the outside, or it's being added or subtracted. We know that that's a translation. But here's the thing, anything inside the root, okay, or inside of parentheses, I call that funky town because nothing is really what it seems in funky town. So inside here in funky town, if you see minus h, you think, oh, well, it's got to be left. You're wrong. It's going to go to the right, actually. So remember that this is funky town. And if it's positive, you're actually going to be going to the, excuse me, I wrote it the wrong way, to the left. And if it's negative, you're going to be going to the right by that many. Okay, so break it down piece by piece and kind of think about what's happening on each one of those numbers, okay? Is it the vertical stretch or shrink? Is it the vertical translation up or down? Or is it the horizontal translation left or right? Okay, so here's how you're going to graph this next one, okay? We're looking at this right here. So let me just go ahead and rewrite it so we have some room to kind of really look at what's going on. So a couple things here. I'm going to color code this. I know this number in front is my vertical stretch and there's a negative. So I know that this is going to be a reflection across the x-axis. I already know that. And this 2 tells me that we're going to do a vertical stretch because the number is bigger than 1 by a factor of 2. So we already know it's going to get taller. And then let's look over here. This plus 2, this is on the outside of the root as well. So remember that's still a vertical change, but this case it's vertically going up or down. So this is a vertical translation, which is just a fancy word of saying a slide. And because it's plus 2, we know we're going up 2 units. And then the last one we're going to do is we're going to look at this right here. So remember, inside that root tells me that it's Funky Town. We also know that it's a horizontal translation. And because it's plus 3, we're going to be going to the right. So we're going to go to the right by 3 units. So let's go ahead and graph it, okay? We're going to graph the parent function and whatever is being multiplied in front. So here's the thing. Step 1, you're going to graph y equals -2 the root of x. Don't worry about the 3 and the 2, the translations first. First, we're going to graph this. So here we go. You're going to go ahead and plug in those points. Let's put, we know it's a square root, so it's got to be positive 0, 1, and 4 are really good ones. So we know -2 times the root of 0 is 0. -2 times the root of 1 is -2. And -2 times the root of 4 is -4. So let's go ahead and graph those points. 1, -2, and 4, -4. It looks like this. Okay, that's just step 1 though. Step 2 is now we're going to do the translations, which is the up, down, left, and right. So we're going to take what we just graphed, and now we're going to adjust it based on what we see here. So in orange, I'm going to say, okay, we know we're going to the right 3 and up 2. So every point, I'm going to go to the right 3. So we're going to go 1, 2, 3, up, 1, 2. That's my new point. Again, here's my next point that I graphed. So we're going to go to the right 1, 2, 3, up 1, 2. And lastly, here was the point we just graphed. So we're going to go to the right 1, 2, 3, up 1, 2. So these orange points are our new points now. Just like that. So this in orange is the graph of y equals the -2 times the root of x plus 3, all plus 2. Okay, now let's talk about what the domain and the range for that would look like. So keep in mind, because this is a regular root, the domain, it's not going to be every value of x. So remember here, it started right here. It doesn't go to the left of x. It only goes here this way, this side of x. So here's where x equals 3. So we say x for the domain can only be greater than or equal to 3 for this particular function. The range, that's our y values. We see nothing up here and above it. There's nothing that exists above it. So we know here, when I go across, this is y equals 2. So we know the highest that can reach is y is 2, but remember it goes below it, so it's going to be less than or equal to 2. So that's our domain and our range. All right, last example. We're going to do this one again, and it's the same steps as before, but this time we're going to practice it with the cubic function. So again, we're going to do step 1. Well, actually, before we do step 1, let's kind of break this down so we know what's going to be happening here. So we know for this first one, this is a vertical stretch by a factor of 3. We know this one outside here is a vertical translation, and it's -1, so it's just going down 1 unit. And then lastly, this one here, this +4, is inside the root. So it's going to be that horizontal translation. Remember, it's Funky Town, so it says +4, but it's really going to be going to the left by 4 units. So we know how this is going to go. Let's go ahead and graph the first part, the first step. So remember, step 1 is we're going to graph just the 3 and the parent function, okay? So we're going to graph y equals 3 times the third root of x. So we're going to pick some of those values that are really easy, just like we did before on our parent function up here. Oops, where'd it go? Here it is. Okay, this was our parent function. So I'm going to pick those values 1, 0, -1, and so on. Okay, I'm going to pick -1, 0, and 1. Whoopsie, wrong way. And I'm going to plug them in. So we go 3 times the third root of -1, which is just going to be -1 times 3. And 3 times the third root of 0 is 0. And 3 times the third root of 1 is 3. So I'm going to graph those points. 0, 0, -1, -3, and 1, 3. So it looks like this. When we graph it. So keep in mind, now step 2 is we're going to do our translations. So we're going to go to the left 4 and we're going to go down 1. So left 4, down 1 from every point. So here we go. Ready? From this point here, left 1, 2, 3, 4, down 1. That's our new point. Second point, we're going to go left 1, 2, 3, 4, down 1. Last point, left 1, 2, 3, 4, down 1. So that's our new graph, and we're going to recreate the shape of what that looks like. And that's our graph. And with a cubic root that we have here, it's going to be all reals. So remember, the domain is all reals because it can go positive or negative in either direction. And the range is also all reals because it can go positive or negative up and down as far as it needs to. All right, and our homework today, or what we're going to work on in class now, is assignment worksheet 3.5 that we can find in Google Classroom.